All right, well, hello everyone. This is Rebecca Dallin. I'd like to officially welcome everyone to this special training session for COSWA members and affiliates. We will begin the main presentations momentarily, so I want to provide some information to help enhance everyone's experience during today's program. In order to reduce background noise, we ask that everyone keep themselves muted during the presentations. If you have questions during those presentations, do feel free to type them into chat at any time. We will be monitoring chat for questions and have our speakers answer as many questions as we have time for today. Everyone in attendance will receive a certificate of attendance as long as we can figure out who you are from your new username on Teams. If your username does not include both your first and last name, please do type that into chat at this time. Up next will be the first presentation for today's webinar. Our first topic will be presented by Dr. Jaime Schussler and graduate student Cheyenne Mata from Oklahoma State University. How about them pokes? Just saying. Okay, sorry. Jaime Schussler joined the School of Civil and Environmental Engineering at Oklahoma State University as an assistant professor in August of 2022. Prior to her appointment at OSU, she received her doctorate in civil engineering from Auburn University. Her research focuses on stormwater management, specializing in erosion and sediment control. Her work aims to find implementable solutions to manage increased stormwater runoff and sediment loads from construction, urban, agricultural, and reclamation sites. Cheyenne Mata is a graduate student in the School of Civil and Environmental Engineering at Oklahoma State University. She obtained her bachelor's in civil engineering from Oklahoma State University in 2022. She is a cooperative trainee in the roadway design squad for the Oklahoma Department of Transportation, and she is researching sustainable design for erosion and sediment control in the stormwater research group at OSU under Dr. Schussler. The title of their presentation is Learning Through Research, Erosion and Sediment Control. Let me stop sharing, and if you would please share your screen. Again, if anyone has any questions during today's presentation, please be sure to type them into chat.
Rebecca, are you able to see our screen?
Excuse me, yes, it just seems small and I'm not sure why, but we can see it.
Okay, give me just a second. I apologize.
Of course.
Is this better?
It is much bigger, yes. We can see all the, ooh, it ran away.
We're almost there. This is the problem when we're plugged into docking stations.
Yeah, I understand.
Okay, but now I'm afraid we're on presenter mode. Is that right?
Yes.
Are we good now?
That's the ticket. That's
Third
the magic button.
time's a charm. I apologize for that. You would
That's
think
okay.
with virtual learning, we've got it figured out, but I appreciate you sticking with me through that. And thank you so much for having us. We're really excited to be here. And this is a really special opportunity for me to get to have Cheyenne kind of co-present with me. So this is really exciting to be able to showcase one of my graduate students' very hard work too. So as Rebecca said, we are going to be talking about the research that I've done in the erosion and sediment control space and some of the more implementable tools that have come out of this. And then Cheyenne's going to present a little bit about her research that introduces a new idea within erosion and sediment control that has to do with sustainable design. So I always like to start out, if you've seen me present, I like to share some pictures or my story around our water resources. And that's because it's just really important to me in my personal life as well. And so it's really exciting that I get to do work in my professional life, that also complements my interest here. And so I care about our water resources for a number of reasons. One, you see this golden retriever, his name is Max, and we cannot keep this guy out of the water. He is our one and only baby right now, and we just want to make sure whatever water he's getting into, because we can't keep him out, is nice and healthy. Also, we love to fish. You can see these are some of my proudest catches. But also, I grew up in the Lower Guyandotte watershed in Milton, West Virginia, and we struggled a lot with water quality and water insecurity. And so this has really inspired me to pursue my education, and then now also research and be doing some mentoring in the stormwater space. And so since 2022, I've been with the School of Civil and Environmental Engineering at OSU. And I appreciate the Go Pokes because we were contemplating what picture to put here. We did think about putting that goalpost in Theta Pond, but we figured everybody has seen that. So instead, these are the lovely faces that make the Stormwater Research Group work here. And so this was us actually just this morning. We went out to do our monthly blue thumb sampling. And so always want to make sure that I'm crediting these awesome students for making it happen. Our group focuses in a number of different things, but primarily looking at changes in land use. So we look at stormwater post-construction. So once we've got, in this picture, our neighborhoods built out, but also during construction. And that's where we're going to focus today, is that erosion and sediment control piece. And this is all really important because we're having a lot of shifts in hydrology. So we're having a lot more rainfall that's happening and very, very intensely. And so we really try to find management strategies to help mitigate the impacts of this changing hydrology on our landscapes. And so stormwater is the name of our game. It's a pollutant source that's actually getting worse. And I've lived in a number of places. This picture on the left is a picture that I took coming off of an Alabama construction site. And I thought, well, is this unique to Alabama? And then, not too long after living here in Oklahoma, I got a very similar picture nearby my house. So a problem that's happening everywhere. And maybe that's because of the way we're implementing erosion and sediment control. Maybe they're just not adequate enough. But whatever it is, we've got to find solutions to get better at it. And so that's what we really focus on. So I keep talking about stormwater, but it's not just construction sites. We know that stormwater from industrial sites and agricultural and urban sites are very difficult and present their own unique challenges. But today we're really going to be focusing on that construction piece because that's where we're seeing those really highly turbid flows come from. And so that's where we're going to be today. And so Cheyenne, can you tell us a little bit about what we know in construction stormwater?
Yeah, hi. So erosion rates in construction are anywhere from 1,000 to 2,000 times higher than natural areas. And the US EPA identifies sediment along with nutrients and heavy metals, which typically sorb into soil as the most widespread pollutants affecting the beneficial use of our nation's rivers and streams. So sediment-laden discharge has some downstream effects, and some of them are increased siltation and turbidity, which can affect our aquatic habitats. It can also reduce conveyance capacities, leading to flooding. It has a poor public perception, and then it also it also can increase the water treatment that's needed later on, and we also get a loss of nutrient-rich soil. The annual cost of soil erosion in the U.S. and is estimated to be $45 billion.
And so just to provide a little background of the picture that we're showing, this was a private farm owner's pond just downstream of a large construction site that I was working on. And so this is just to provide some context that what we're doing on our site has real implications to people very nearby. And it could be any number of these effects, but especially with that poor public perception, if this was your pond and you were going to have to figure out a dredging plan for it after the construction finished, you would probably be wishing the people upstream were doing a bit better. And so what are we doing about it?
So the US EPA has their National Pollution Discharge Elimination System, and within that is our construction general permit, which helps combat the loss of soil on construction site. And in Oklahoma, that's our OKR 10 permit. So some of the requirements of the construction general permit are you have to submit a notice of intent if you plan to disturb more than 1 acre, and you also have to have a stormwater pollution prevention plan. So stormwater pollution prevention plan is a living document that includes the design, installation, and maintenance of erosion and sediment controls. So what are erosion and sediment controls? Well, erosion controls work by absorbing or diverting energy, slowing the velocity, reducing dust, binding soils, or increasing the ability to absorb and infiltrate water. And then we have sediment controls, which work by intercepting flow, creating an impoundment, or providing volume and time for that sediment to settle out.
And that's great that we have some of these practices in place, and some of them go from state to state. But there's a lot of design guidance that's quite variable. And so that's one of the things that we try to address with performance-based or scientific-based research to try to really say, instead of just, oh, this is a best management practice, trying to put some ground truthing into that with data. And so that's one of the things that we often put in these practices out of rules of thumb, but we lack that true knowledge of how practices perform, and even more so how they perform during actual construction. The other thing we see is more on improper installation or maintenance. Maybe this is from lacking resources or just lack of knowledge. And so that's one of the things that I'm very passionate about, is that we're trying to spread the good word of what erosion and sediment control is and how these practices should be performing. The other thing is, Cheyenne mentioned it, a SWIP is a living document. And so we need to be inspecting and updating our SWIP. And sometimes we just don't have the power on site to be able to do that, the man or woman power that is. And so there's a huge divide when it comes to the design of these practices. So we're going to focus largely in the ditch check space or check dam space today. Some that we'll talk about are riprap, silt fence, and wattles, or some people call these socks. And so this is really what we're going to focus in on for the majority of our presentation, with some small deviations. Now, in this last image, we see a lot of newly installed ditch checks or check dams, and they're doing great, or we expect them to do great once that rainfall comes. Storm, and this is often what we're going to see on site. These are all pictures that I have taken from actually working on a linear construction site. And so we see these ditch checks are just absolutely inundated. They're falling over. We're not quite sure when they fell over or maybe why.
Jamie, I don't know if you can hear me, but we have lost your audio.
I wanted to look into that.
Oh, goodness.
Did you have an issue?
Your audio for a sec.
How long has it been?
It was probably about 15 seconds. We were looking at that last ditch check picture.
Okay, that's all right.
And we don't know how long they've been in that state, I think is kind of where you were at.
Right, exactly. Thank you, Rebecca. So
of course,
we're not sure what caused this, if it's the sediment load, if it's hydrostatic pressure from channelized flows. And so we really wanted to identify what we could do to improve this. And so what we did was we did weekly inspections, so installed a number of ditch checks in various installations. We did weekly inspections and monitored the rain. And then we also did surveys, so that's ground surveys to track the channel erosion and sediment deposition. And this is part of our effort in putting numbers behind the performance of some of these practices. So this is our standard silt fence ditch check. I was working on an Iowa DOT site. So this was just a silt fence installed perpendicular to the direction of flow, and just staked, I believe they were 4-foot spacing on this. And so over time, this was after 12 inches of rainfall, we see some vegetation that's happened upstream in this channel. And then downstream, maybe not so much. We also see this T-post that's deflected and maybe some evidence of undercutting here. And so when we looked at 3 different instances of the same installation, and we found on average, we were capturing a half of a cubic foot of sediment on one of these silt fence ditch checks. And so we looked to other places. As I mentioned earlier, the designs really are variable. And so this was a silt fence ditch check that we saw being used in the southeastern portion of the US. And this was a V-shape silt fence ditch check. It was cut slightly lower at the vertex, and this was to create a weir or a known dewatering point that we could control. And that way we were hoping if we can control the hydrostatic pressure, then maybe we're not going to have that T-post deflection. The same thing you'll see here, we have like a chicken wire or a wire mesh reinforcement. And just visually, we can see that the sediment impoundment goes much further back in the channel. And when we put numbers to that, we found that we increased the sediment captured on one of these ditch checks by about 4 times. So this is just evidence that our designs are really variable. We call them all best management practices, but really some are performing better than others. So same idea here with a wattle ditch check. This is a wattle inside our wood chips, and then we have that sock encasement that's laid down in the channel and just staked directly through. Again, after the same period of time, we looked, and on this installation, we were capturing about 0.1 cubic feet of sediment. And so, again, look to other standards, maybe something a little bit beefier. We changed that wattle installation to use this non-destructive or A-frame type staking. We have a natural fiber that's an Excelsior mat laid down in the channel, and we use some sod staples to really create that contact between the wattle and the ground. And what we saw is that we increased sediment deposition captured on that wattle by 12 times. So there's something to this. So again, just to give us an overview of where we're at from these standards, we looked outside to maybe what other places were doing, put these installations in during actual construction and monitored, and we were able to improve performance. Now, for us, this resulted in a design modification for the Iowa DOT. So especially in that wattle, that's what's being shown here, is we changed from that standard and went to that non-destructive staking and implemented that sod pin. So this was now adopted into their specifications of how wattles should be installed in a ditch. So that's a pretty tangible change from performance-backed research. And so on the site we were working on, there was actually 3,500 ditch checks that were going to be implemented over the site, and that's all ditch check types. But we went ahead and extrapolated this data of what it would be if all the ditch checks were changed to these modified standards. And so with the standard silt fence design, we would have captured about 4.5 truckloads of sediment on these practices. If we did the modified design, we would have captured 18 truckloads. So with this knowledge, if you are not improving or putting in performance-backed erosion and sediment control practices, you're essentially dumping 13.5 truckloads of sediment from your site into the receiving waterway. And so this makes this all a bit more tangible if we can visualize. Same thing with the wattle. So that standard wattle, if we put all standard wattles in as ditch checks, we would have only captured 1 truckload of sediment on site. Whereas if we put in that modified, we're capturing 14 truckloads of sediment on site. Again, essentially dumping 13 truckloads of sediment if we don't make these changes. And so this is one way that research has helped us, come up with really informed erosion and sediment control designs and to help influence standard. Now, the one thing that I want to say, and we can see just by looking at this image, is there's more components now. There's more components on this modified wattle. So now we have these sod staples. Now we have an extra stake. So what is the increased cost? We also have to disseminate this to the people who are going to.
Julie, we lost your audio again. Or Julie, Jamie. Brain is broken.
And this is really.
Oh, yep. You may want to not share your video. That might help save some bandwidth for you.
Okay, I can do that. So talking about ditch check spacing here, we talk about spacing as a function of the height of the ditch check practice. And so our ditch check spacing, we consider the height of the practice and also the slope of the ditch. And the goal of this is so that wherever the impoundment ends is where we would place the next ditch check. And this is to create that stair stepping down the channel to reduce those erosive forces and create these impoundments where sediment can settle out. Now, oftentimes we get improper spacing, and so we'll get these areas of subcritical and supercritical flow. If you're not familiar with those terms, that's okay. Subcritical flow is what we want in erosion and sediment control. These are slow moving, deeper, what I call gushier flows, whereas supercritical are going to these shallow, fast-moving flows that can be very, very erosive. And so we want to make sure that when we're designing with ditch checks that we're using the proper spacing. And so we looked at a number of different wattle practices because with wattles, we see there's a variety of fills and encasement materials, and they allow water to pass through at different rates. So we looked at several that were, very widely used and available. Maybe you'll see some that you're familiar with, some with straw, some with Excelsior. We even have triangular silt dike here. And we measured the height of the impoundment, and that also correlated with how far back the impoundment was going to go so that we could figure out that spacing. And from that, we came up with this ratio of the length ratio, so how far back the impoundment was going to go. And that way, if wattles were allowing a different flow through rate, we could properly space them using this impoundment ratio. And so we brought all of these things together in a tool called Check Spread, which I'm going to show you today. And so this tool, we created out of the outcomes of our research. And so we allow users to toggle in between different ditch check types. They can input their channel geometry. And then this will let the user know how many ditch checks they're going to need, what that spacing should be. And then I just want to be transparent here. It gives a cost estimate. We did this cost estimate based on the site we were working on in Iowa. So it might not be perfectly representative for Oklahoma, but we used the costs there that were available to us. And so I'm going to show you that tool, what that looks like. And all you would need to use this would be simple Excel. So if you have Excel, then you're able to open this tool. Anything that is shown in red text would be user input, and then the black text is going to auto-populate here. So this is just the front user page. That's what you would need. And then this reference page, which is locked with various different calculations, and then also the cost component of it. So here,
Jamie, I don't know if you can hear me, but we lost your audio again. Challenging internet
options,
day. Can you hear me, Jamie?
I can hear you. Yes.
Okay,
I am going to try to hardwire my computer.
Okay.
To Wi-Fi and see if that will help us at all.
It's just one of those days.
There it is. I so apologize. I hate that. And so I think you're still probably seeing too small.
I can hear you, if that helps.
Yes. I won't curse my computer then if you can hear me.
Probably safest.
I'm just teasing. Okay, so are you able to see an Excel screen now?
No, we're seeing a black screen. It's like it's trying to share, but it's not sharing anything.
Doesn't want to share.
While you're working on that, I have one person that I would love to ask if you would provide in chat your first and last name. We've got Chris. Looks like Chris's video is on and he has stepped away, so maybe he can't hear me. I don't know. And then there was somebody else who has left the meeting. Okay.
Are we back on, Rebecca?
Yeah, I can hear you. Thank you.
And you can see?
I can see Iowa did check design and cost estimate.
Great. So we're where we need to be.
Yes, thank you.
Yeah. So all I was saying is that we took all of these different research findings, some from the field, some from the lab scale, and we compiled them to be able to create an Excel tool. So anybody who has Excel can use this and access this. And so just to help with the design, so putting in these research findings into design. And so we have this user interface page here on the front, and then there's a second page that has a lot of reference equations and cost material. What's in red would be our user input, and black would be what the tool gives you directly. And so here in this drop-down ditch check type, we have several different types. The silt fence standard that I presented on, the modified silt fence design, some various rock check dam designs, and then also wattles of different sizes. And so I'm going to go between these silt fences first, and I'll leave the channel geometry the same here. And so what this tells us is that our silt fence, according to this design, is 1.6 feet tall. And so the spacing between these is going to be 52.8 feet for a 3% channel slope. So for our channel that we've put in here of 200 feet long, we're going to need 4 of those ditch checks. And then it would estimate the cost for us. And so we might say, okay, well, we had gone into this project thinking we were doing all standard designs, but now I might want to go to the modified silt fence. And so what does this look like for us? And so if we change that to our modified, then we have those additional components like that wire reinforcement, and maybe we have some extra T-posts. And so we've increased the cost here to $160, but that cost is, in my mind, would be worth it to be able to capture so many more truckloads of sediment on site. But we know that a lot of people love to use wattles in their ditches as well. So we could pick between that standard or that modified wattle at both 20 inches and 12 inches, depending on what you use and what's available in your site. So if I go with this wattle, the standard installation, that's 12 inches tall, and we can start with a straw net, but we can also toggle between wattle practices here. That's where the that impoundment factor or impoundment ratio I was describing comes into play. So we could switch this between straw or miscanthus or coconut coir, whatever you like. For straw, which is pretty typical, we see a lot of, we know the impoundment factor is 0.72. And so that's going to come to play in our spacing. So with a 12-inch wattle that's 1 foot high, we need to space these wattles out 24 feet. So for that same channel, we're going to need 9 of them total. And we increase that cost by about $5, but sometimes we just like to install wattles. They're maybe a little bit quicker or easier, more accessible. And so we could switch this from that standard wattle installation to the modified installation. And again, now we have that fiber, natural fiber underlay, some sod pins, and some extra stakes. And so we've increased the cost, but again, now we can do kind of this cost benefit analysis of, we're going to be capturing a lot more sediment, but we also may need to, put our money where our mission is. So that's the gist of this tool, just to be able to put some of this research into practice. And so I'm going to jump back over to my PowerPoint and just very quickly highlight that we've also done a lot of work with sediment basins and specifically in conveyance channels. So creating detention areas in these drainage channels on site, not in natural streams, just to be clear. And so it was the same thing that we're seeing with the ditch checks, is that over time, we were having some issues with these and performance was really variable. So we suggested some different design components and tested and validated them, which is a separate presentation. But we ended up suggesting some various different storage areas, one being a standing or a permanent pool that helps dissipate some of the inflow energy and helps from resuspending previously settled material. A stormwater storage volume, this would be for that 3,600 cubic foot per acre or your 2-year 24-hour storm, depending on how you're designing. And then also this auxiliary flow, which is for one of our larger storms. And so that would look something like this in the water column. And just as we did for ditch checks, we don't think that research is any good unless people can use it. And that's one of the big drivers behind these tools always being based in Excel, because this is an accessible way for a lot of people to use. So this sediment basin tool, it allows the user to put in as much or as little of this information as they want, and it will produce a design based on that and give you some information. You can put in your channel configuration, what your dam looks like on these sediment basins, and you can toggle between dewatering structures. So whether that's your traditional riser pipe or a skimmer or even just a rock outlet. If you have soil information for your site, so a site soil gradation, we can put that in and based on your sediment design, tell you what percentage of that soil that we expect to be able to settle in the basin's detention time. That's based in a law called Stokes Law, and it pulls in temperature, If you don't give us temperature, we're going to assume it's between 65 and 70 degrees. And then if you have a hydrograph routing, we could tell you exactly the flows we would be expecting leaving your basin as well. So just a couple of different things here. I won't spend too much time demoing this, but if sediment basins are something that you are interested in, and this tool could be beneficial for you, I would be happy to share that with you. Based on this input information on the far left, we give you what your channel cross section would look like, a stage storage curve, and then also your stage discharge curve. And then we tell you the volume of those different storage areas. If you would like to use a skimmer, this tool will also automatically size the skimmer for you as well. If you use the hydrograph routing feature, we will give you an inflow and a discharge hydrograph. So you could see that. And then also the dewatering for both stage and storage, you can see at the very bottom. And we would tell you your total runoff volume, the total outflow volume from your basin, and storage at the end of the routing. That last piece being that site soil gradation. So we would give you, if you were able to input this information, we would give you the curve, and what is highlighted in green are the fractions we would expect to settle within your detention time, and red is what would stay suspended. If you're interested in use of flocculants, I love to preach about flocculants and tell all about them, but we say if less than 80% of your soil is not expected to settle, then we recommend flocculants to help you drop out those finer particles. And so this is a really high-level overview of what this tool can do. But again, I'm happy to spend time and share these tools with anybody who could benefit from them. So with that, I'm going to pass over our last few minutes for Cheyenne to present her research.
We are still seeing your Excel. I thought you were going to transition to back to your PowerPoint.
Thought I was presenting as if I had done that.
That's okay. I wasn't sure and I didn't want to interrupt. But...
Nice, Rebecca. So some of the things that I
okay.
That I quickly went over. Not an easy technology day at Oklahoma State. Jokes we will accept. So these were just some of the quick slides. I showed that a lot of times our erosion and sediment control practices just aren't going to stick with us. Throughout the site, we really need to make sure we're inspecting, maintaining, and adjusting our design. So that's exactly what we did. These were those areas I was talking about with storage. Rebecca, I'll share all these slides with you. That way, if anybody wants to spend a bit more time, they are more than welcome to. And this was showing some of the outputs of our sediment basin tool as well. So a couple of things with channel cross sections, stage storage curves, that sort of thing. Again, more information here about your inflow and discharge hydrograph and what those volumes look like over time. And then finally, what that sediment gradation could do and what we would predict to settle based on that. So now I will pass it over to Cheyenne and send her the good vibes and hope she has better luck than me.
Okay, hi again. So my research does like a cost and environmental assessment of erosion and sediment controls that are used by departments of transportation. So this is looking more nationwide. And so like we were talking about earlier, the design, implementation, and the cost of these erosion and sediment controls can vary from state to state. And so when we're making these erosion and sediment controls, They can be made using natural or synthetic materials. And what we're seeing as we're using these synthetic materials, we're getting some environmental impacts. So some of these synthetic fibers are left behind after construction is complete, and we're seeing that wildlife is getting caught in them. And so one of the main ones is snakes are getting caught, or small birds, and it's causing this like ecological impact. And so people are looking into how to make these more sustainable if they do get left behind. And so the objective of my research is to quantify the environmental impact and to characterize the spending of some commonly used erosion and sediment controls. And so to do this, the first thing we looked at was cost. And so to do this, we distributed an online survey to stormwater program managers at 50 state DOTs, as DOTs are some of the major facilitators of construction. And this map on the left side, the green shows states that have responded, and then the white just shows states that are still pending responses. And so what we did in this questionnaire is we asked them a few questions. So the first question we asked them is the number of constructional general permits that they had under their management. And so the survey was sent out in 2020. And so all these numbers are regarding the year 2021. And so the number of permits that a state has depends on the size of the state, and then the regulatory agency. So some states have as low as 1, whereas other states like Minnesota has 250 construction general permits under their leadership. And then we also asked DOTs how many DOT-led and how many contractor-led inspections were conducted in that year. So within the construction general permit, it says that inspections are to take place every 7 or 14 days, depending on that site's proximity to an impaired water body. And then also, no matter what, they have to be conducted 24 hours after a storm event. And so we see that these inspections range quite a bit. So Pennsylvania had almost 10,000 inspections, whereas some states like Maine maybe only had 100. This also just kind of depends on how many projects they have under their under their management. Depends on how many inspections they're going to conduct. And these inspections, so like we were saying, we want to continually inspect to see that if something is failing, we take it out and replace it. So these inspections can also influence the quantity of the erosion sediment controls that are used, which is what I'll talk about a little bit later on. We also asked DOTs to report the percentage of total project costs that's spent on stormwater management. And we saw that an average of 2.35% of total project costs is spent on stormwater management, with your upper limit being about 15% and the lower being about 0.23%. And then we also asked DOTs to report the average bid cost and quantities of erosion and sediment controls. So right here we have silt fence and wattles, as well as riprap. So when looking at these cost-wise, we can see that your silt fence, which is going to be made out of your synthetic material, is going to cost less than your wattles, which wattles can be made out of natural and synthetic materials. And we can also see on our quantities that silt fences are favored by quite a bit. Only Iowa, Arkansas, and South Carolina reported quantities of wattles, so silt fences are more favored. And then we also put in riprap because riprap can be used as what we call like a rock check dam. And we can see that riprap is going to cost quite a bit more than both silt fence and wattles. And then the next part of my research was to do a life cycle assessment. So to do this, I looked at Oklahoma and Iowa DOT standards and specifications. And then I cataloged each of the practices. So I broke the practices down into individual materials. And then I set sample boundaries. So I did a trapezoidal channel, 100-foot run of perimeter control, and then 1 acre for erosion control. And then I used a software called SemiPro to give me outputs of different categories of environmental impacts. So when looking at the materials that are used in these practices, I only looked at the material extraction and the manufacturing phase of a material's full life, since this was more of like a nationwide survey. What happens after manufacturing, so distribution, usage, and then end of life management, just depends on the state, the contractor, and things like that. So I wasn't able to look at those phases of a material's life. And then within SemiPro, each output that I got was either 1 kilogram or 1 meter. And so we had 10 impact categories that we could look at within SemiPro. These top 5, so ozone depletion, global warming, smog, eutrophication, and fossil fuel depletion, were the 5 main ones that we were concerned with. We looked at all 10, but these were just the 5 that we focused on. And so this kind of goes back to my first step of cataloging all of the materials that were used. So on your left, you'll see 2 different standards. So you'll see Oklahoma standard and Iowa standards. And so what I did was I cataloged I broke that practice down into individual materials. So Oklahoma is going to use cable ties, C-rings, an engineering fabric, steel posts, chicken wire, and then a turf reinforcement mat in their design. And these steel T-posts and these wooden T-posts are interchangeable. So that's why you'll see Oklahoma S1 and Oklahoma S2. And then the same thing goes for Iowa. Iowa uses cable ties, engineering fabric, and either steel or wooden post in their design. And so then I came up with a quantity of these materials, and to do that for the trapezoidal conveyance channel, we created our own channel that had an 8-foot bottom and then 3-to-1 side slope. So that's how I was able to come up with all of these quantities, like the 3.14 meters, the 4.58 kilograms. Those came from that trapezoidal channel design. And then I also looked at wattles for each of these states. So like talked about earlier, wattles can be either done using destructive or non-destructive staking. And then I just did the same thing. I just cataloged all the materials and then found the weights of them. And then SemiPro gave us the outputs that you're going to see on the right. And so to compare these, we normalized the data. And so to normalize the data, we took the highest, we identified the highest emissions out of all of them. So you'll see like right here, silt fence for Oklahoma has the highest emissions when compared to Iowa silt fence. So we took that lowest value and put it over our highest value and then multiply it to get like a percentage. And then we put it into a graph, and this is what we got. So this is for our in-channel practices. So what we're seeing is that our Iowa wattle 1, so that wattle had a jute netting and a straw fill. That is going to have our highest emissions in ozone depletion and in eutrophication. And then we see that our Iowa silt fence 1, which is going to have steel T-post, it's going to have our highest emissions in global warming, and then in smog, as well as in our fossil fuel depletion. And so wattles, jute isn't a natural material to the US, so it has to be brought over. And so that's going to cause quite a bit of emissions. And then for our Iowa silt fence, the spacing between those posts is shorter than when you're looking at Oklahoma. So you're using more steel in that way. So that's why we're seeing higher emissions in that area. Can't move. Oh, yeah.
You just switch this.
Oh, did I move? Oh, sorry. And then when we looking at trapezoidal channels, we broke them down into silt fence and into wattles, so that we can look at them separately as well. And here we see that Oklahoma silt fence has the highest emissions in ozone depletion, and then Iowa's silt fence has the highest emissions in our global warming and other categories. And then we just did the same thing for wattles, and we saw that Iowa's wattle had the highest emissions in ozone depletion, global warming, smog, and eutrophication, and then their second wattle had the highest in fossil fuel depletion. So our findings showed that natural products did not have a lower emission in the manufacturing stage. However, this study does not suggest like the removal or the exclusion of components, as this can compromise the performance of practices. So while we're reporting these findings, it's not to say that just because something has higher emissions doesn't mean that it's going to perform less or better or worse than other practices.
Thanks. Yeah, and so with Cheyenne's research, it's not to say that we need to maximize our T-post spacing, because then we might have problems with performance. But we see a lot of the shift from synthetic materials into natural materials for reasons that she mentioned previously, because a lot of times these are getting left behind in the field. We're seeing some wildlife entanglement. So there's been a big push to go to these more natural materials. But there's also now a desire, especially to try to reduce greenhouse gas emissions, to do some of these like environmental product declarations to say exactly what goes into making these products. And so Cheyenne's research is really early into this field of trying to figure out exactly what happens when we do material extraction and we do the manufacturing of these products. What is the environmental impact just of that use phase? So again, not really suggesting anything based on design right now, because we might need more T-posts to make sure that our practices are structurally sound, or maybe that wattle is the most appropriate in that application, but just knowing and being conscientious of what goes into the manufacturing of these materials. So together, we're hoping that we have inspired you to think about current design practices, challenge the NOMR of best management, and really let's try to work to find that, especially in our current and projected hydrology. Also, in engaging in these knowledge exchange. If we just stayed siloed and into what we were doing only here in Oklahoma, instead of really pushing ourselves to think outside and think more globally and doing that knowledge exchange, we would have never come up with some of these design alternatives. So really just talking with your neighbor and figuring out what's working for them, and it might work for you too. And then also just the importance, I feel it so strongly as a researcher, that research is no good if there's not a way to implement it. And so that's one thing that we're really passionate about, is exchanging our knowledge and providing technological aids to help with the design of this. And so again, we really appreciate the opportunity to share this, and I'll share my slides with Rebecca and whoever else is interested in having those, and I'm happy to talk with you more on the tools. I know we have a second portion of this presentation. So Rebecca, I'm not sure how you wanted to handle questions, but my email is shown here. And so feel free to reach out anytime. I really appreciate it.
All right, thank you, Jaime and Cheyenne. What a great presentation. We do have a couple of quick questions. Jordan?
Yes, can you hear me?
Yes.
Okay. Yeah, we did have two questions. The first one was just a request for the presentation slides, Jaime. So there's definitely interest out there. So we'll distribute those slides to the attendees after the webinar is over. The second question was from Wayne Craney, and he was asking for the design storm that you used as part of the ditch check analysis.
Sure. So with the ditch check analysis, we weren't actually running storms through that. So that was more just on the design side of things. So what your spacing should be based on channel slope, and then also the function or the height of your ditch check practice. Now, maybe for design storm, we're talking on a sediment basin side. And so if so, we were just, you can plug in whatever hydrograph you want into the tool that I was showing. With stormwater storage in sediment basins, what is typical is that we're providing 3,600 cubic feet of volume per drainage acre. Other states are using the 2-year 24-hour storm to figure out the volume. And so, but those are, depending on where you are, your stormwater storage volume is going to change. But typically when we're working with design storms in erosion and sediment control, we're using 2 years. And the thought is that on large construction projects, they're going to be open for about 2 years. So the chances of us getting that storm is, is pretty probable. Even if your construction site is open for a shorter amount of time, with the way hydrology is working right now, I don't think it would be a bad idea to think about maybe even a larger storm. So I hope that answers it, Wayne. Always happy to talk with you, if you have some more questions there, but thank you all.
All right, thank you so much. If anyone still has any questions for Jaime, we can probably put her email address into chat here in just a sec. But up next is the second presentation for today's webinar. We're going to be hearing from Vernon Seaman. Working for the Indian Nations Council of Governments, or INCOG, since January of 2007, Vernon Seaman started as their senior environmental planner. He later became the manager of the Environmental and Engineering Department, holding this position until his semi-retirement at the end of July of 2022. At that time, Vernon became INCOG's water quality specialist and continues to work part-time on water-related and environmental projects, issues, and concerns. Prior to working for INCOG, Vernon spent 21 years in commercial environmental analytical laboratories in Oklahoma. During this portion of his career, he was involved in the sampling, testing, and reporting of water, soil, sludges, fish tissues, and various other materials. His roles at the laboratory included the regional and laboratory manager from 1999 to 2006 at Accurate Environmental Services, the director of environmental services and QA/QC officer from 1992 to 1999 at Sherry Laboratories, and the environmental manager and QA/QC officer from 1986 to 1982 at Williams Brothers Laboratories. Vernon received his Bachelor of Science degree in biology from St. Ambrose University in Davenport, Iowa in 1982. During his professional career, he has worked closely with various state and federal agencies and served on numerous boards, technical work groups, and committees. Helping customers and clients solve environmental issues in a cost-effective manner and understand the rules and regulations covering the numerous aspects of water, air, soil, and waste has been his lifelong passion. With that, the title of his presentation will be TMDLs and Implementation in MS4s and the use of QAPPs. Again, if anyone has any questions during this presentation, be sure to type them into chat. Go ahead and share your screen if you would, Vernon.
All right.
And while you're doing that, I'm going to ask a shout out again to the attendee named Chris, who is logged into this webinar. If you could provide your last name into chat, that would help us get you a certificate of attendance. All right, we can see your screen, Vernon. Please go ahead.
All right. So for the next part, what we're going to focus on will be the TMDL requirements in your OKR04 permits. So what does the permit say about TMDL? What are the requirements in the permit? And how are you going to go about implementing some of these? Okay. All right. So first off, let's just talk about just briefly, what is a TMDL? It's a total maximum daily load. It refers to the maximum amount of a pollutant that a water body can receive and still comply with the state's water quality standards. So a TMDL is expressed as the sum of all waste load allocations, the load allocations, and an appropriate margin of safety, which takes into account the uncertainty between the model and the actual environment. So the definition that we frequently use is The calculation is shown below. The WLA underscore WWTP, that's the waste load treatment plant or permitted discharges. Plus you have your MS4 waste load allocation. And then there's the LA portion, the non-point source loads that go into the calculation. And then finally, we have a margin of safety. All calculations, TMDL calculations, modeling events, there's some error. And so the goal is to try to minimize the error by increasing the quality and quantity of data or inputs we put into the model so that, in fact, the model does represent real-world conditions. A quote I've always remembered from many, many years ago, all models are wrong, some are useful. George Box was kind of the guru years ago on modeling, and there's so much truth to that. The more information you have, the more accurate your model is going to be. And so that's the whole point of gathering data, and we'll be talking about more of that as we get into this. So, but that's basically what a TMDL is. It's the state's calculation of what the load that receiving water can receive and still meet state water quality standards. Okay, so how is a TMDL created? It starts with the water quality monitoring aspect. You've got to gather the data. You have to have data to put into the model. That can be from state agencies, federal agencies, local agencies, wherever we can get the data that is suitable for the modeling project at hand. And then you assess the data. And so the state agencies will assess the data they have and determine whether that water body is meeting the water quality criteria standards. If it does not meet the standards, it'll be placed on the 303D list of impaired water bodies. So, and then after it's on the 303D list, if that water body is on the 303D list, then there are so many of them. Obviously, the state cannot get around to writing TMDLs or preparing TMDLs for everything that's impaired. And so they have a priority project or program or rating system that they use to assess a priority to each water body, which ones are going to get prioritization for TMDL establishment. So they'll go through that, rate them all. Once a water body, impaired water body, is determined to need a TMDL and it comes up in its list, the TMDL development will occur. And so that's a fairly long process. It can take quite a while. Oklahoma does some of its own TMDLs. They contract some of that work out. But in the end, they're going to end up with a TMDL. And a good way to think about the TMDL is it's basically the state's plan to fix the problem. Okay, the problem being the impairment. So once the TMDL is ready to go, they're going to release it for public review, and that's where you look at the TMDL, review it, go over it, and then offer comments. And then DEQ will review the comments, make changes if they deem those necessary. After that's finished, they submit the TMDL to EPA for review. And then EPA, if they approve the TMDL, then it comes out as a final and it's ready to go. So now let's get into the permit itself. And we're just going to confine our discussion to what is in the permit. There's a lot of additional information you can find all over the place on TMDLs, how to implement a TMDL, which BMPs or best management practices are most effective. But let's stick with the permit. What does a permit say that a permittee or an OKR04 permittee must do to comply with the requirements? So the most recent permit, OKR04 MS4 Phase 2 permit, came out June 1, 2021, and TMDL is mentioned 77 times in that permit. So it does pop up over and over again. It's an important aspect of that permit. For many of you, most of you, this will be your first dive into TMDL compliance requirements. So just getting started on that. And so what I'm going to do is just pull out passages in the permit, and then we're going to discuss those passages and what they mean. So part 2 of the permit, coverage under this permit. 2C says limitations on coverage. Point 6, discharges not consistent with the TMDL are unauthorized. Discharge of a pollutant in any water for which a TMDL or watershed plan in lieu of a TMDL, and you can write watershed plans in lieu of TMDLs. So for that pollutant has been either established or approved by DEQ or U.S. Environmental Protection Agency, EPA, is prohibited. So unless your discharge is consistent with that TMDL or wastewater plan, basically what that means is if you have a TMDL and you have discharges to that TMDL water, then anything that does not comply with the TMDL is considered an unpermitted or prohibited discharge. So that's why it's important to understand what's in the TMDL and what your obligation is. If you don't comply with the TMDL requirements, then the DEQ considers that an unpermitted discharge. Section 4B1 says SWMP review and modification. Your MS4 shall evaluate the existing SWMP, your stormwater management program, in relation to the TMDL reduction goals. Any resulting modifications shall be implemented within 2 years of the effective date of the TMDL and then as needed. At a minimum, your evaluation shall provide and identify each of the following items and information. It goes on to talk about what you have to address in there. There's a few more passages in the permit that discuss SWMP updates and modifications. And so what we're going to see is there are some discrepancies in the permit about, concerning when your SWMP needs to be updated to include TMDL requirements. So the main message on this section here, 4B1 states effective date of the TMDL. So you have 2 years from the effective date of the TMDL. And what we'll see later, since the permit came out June 1, 2021, but the effective date of TMDL requirements in the permit is June 1, 2022. So according to this passage in the permit, effective date of it's 2 years from the effective date of the TMDL. So that gives you the effective date of the TMDL is 2022. So you have until June 1, 2024 to complete a review and update of your SWMP to include TMDL requirements. So that's one passage. Now, if you go on to section 5A1, it states renewal permittees must review your SWMP and, if necessary, revise and update existing and/or develop new BMPs and measurable goals in your SWMP to meet the requirements of this permit or as required by the director to ensure compliance with the CWA or Clean Water Act. Modifications and updates shall be reflected in your SWMP and implemented within 2 years of the effective date of this permit and then as needed. So we've got 2 more things in here. The director, DEQ, can basically change requirements and conditions if they see the need. Okay, so when do you have to update your SWMP? Well, it can be 2 years from the TMDL effective date, which would make it 2024, or the last line or section in this particular clause, 2 years from the effective date of this permit. So the permit came out in 2021, so that would mean your SWMP would need to be updated to include TMDL requirements by June 1 of 2023, this past June. So some of you have already completed your SWMP updates to include TMDL, so you're finished. That's good. Some of you are still working on it, may not have completed that. If you look at the other passages, it goes on to say 2 years from the effective date of the TMDL. That gives you to 2024 for that. Regardless, if you've already completed it, wonderful, you're finished. If you haven't completed and updated your SWMP, you do need to be working on that because everybody is in agreement that everybody's SWMP should be completed no later than June 1, 2024. So, and then VB1 required SWMP update states, as determined by the director, DEQ may require changes to be made to your SWMP to meet permit requirements. Such changes may be necessary to, and then section C says, include other conditions to comply with the goals and requirements of the Clean Water Act, including TMDL requirements. So DEQ has discretionary authority on when these portions need to be completed. So basically, I guess the bottom line, the take-home message here is if you've already updated your SWMP to include requirements under TMDL protocols, wonderful, you're finished for now, but your SWMP obviously is a living document. You're going to update it. You're going to review it every year and update it as needed. So, but if you have not completed an update of your SWMP to include TMDL requirements, you need to be diligently working towards that end. All right, and then V period D, reviewing and updating SWMP, goes on to state you must conduct a review of your SWMP at least annually in conjunction with the preparation of the annual report required under Part 6C. Your SWMP shall be modified as needed during the life of this permit. So what they're saying here, your SWMP, you're going to review that annually, at least annually, or as needed. You're going to review it at the time you prepare your annual report, and then you're going to modify it during the life of this permit, whatever modifications may be necessary at whatever frequency. So keep an eye on your SWMP, your stormwater management program, and make sure you're documenting what needs to be done and what you are doing under the TMDL requirements. All right, annual reporting. Section 4B6 states annual reporting. Your MS4 shall include a TMDL implementation report as part of your annual report. The TMDL implementation report shall include the status and actions taken to implement the TMDL pollutant reduction plan and monitoring plan. The TMDL implementation report shall provide, and this section goes on to explain what needs to be in your annual report regarding TMDL requirements. So even if you, at this point, some of you have, most of you, probably very few, if any of you, have started collecting samples. Because again, before you collect samples, we'll talk more about this as we get farther into the program here, but you do have to have an approved co-op and you do have to have a monitoring plan before you start collecting samples. So at this point, you probably haven't started collecting any samples. However, there are a number of things that you can be doing. You can be looking at maps, aerial reconnaissance of your area, identifying which TMDL water bodies are within your jurisdiction, which tributaries feed into those TMDL waters, where likely sampling sites could be located within your jurisdiction, what parameters are listed in your TMDL, what are you going to be testing for? For most of you, it's going to be bacteria. Many of you have turbidity. There's a few other parameters. We'll look at those later on too. But for the most part, what you can be doing and should be doing is identifying which TMDLs you need to comply with, and then reading those TMDLs, getting familiar with the requirements in those TMDLs, so you'll understand what your long-range plan is, what your goal is, what obligations you have under that TMDL. So when it comes time to prepare your annual report, even though you haven't started collecting samples yet, you aren't doing any analytical work, you are still working towards compliance. So you're doing the groundwork, the footwork on this. You're identifying the TMDL water bodies, you're getting copies of your TMDL reports, you're getting familiar with those TMDLs, you're understanding what your obligation is under the TMDL. So you need to state that in your annual report. So there should be a section in each of your annual reports just labeled, TMDL implementation program or something to that nature, and then explaining in your annual report what you have done so far. So DEQ expects to see that if they get an annual report or review an annual report and it doesn't have a section on TMDL, then you're missing a portion. So even though you haven't started collecting samples, you still have, there's still things that you can be doing to getting ready or preparing for TMDL compliance. So make sure you do have a section in your annual report that addresses TMDL requirements. All right, so our implementation schedule. So 4B7 states TMDL implementation schedule, the SWMP review and modification, TMDL pollutant reduction plan, and TMDL pollutant monitoring plans shall be implemented as outlined in Table 4-1. Let's take a look at that table. There's been some confusion over what does this table mean and what are my options? What is the best route for me to take? Because you do have a choice here. So if we look at this table, and this again is table 4-1 in your permit. So what you'll notice, the very first line in that table says SWMP review and evaluation. So here the table says no more than 2 years from TMDL effective date. And we'll see later the effective date is June 1, 2022. But remember, there's passage later on that says your TMDL, your SWMP update must be no more than 2 years from approval or activation of the permit itself, which would be this past June. Okay, whether you take option A or option B, it's the same. Okay, so SWMP review and evaluation is the same whether you take option A or option B. So let's talk about option A. The TMDL, what you'll notice when you move down the table, it says TMDL pollutant baseline monitoring plan. And when you look at option A, that's grayed out. There is no TMDL baseline monitoring plan needed because if you take option A, you're going to skip the baseline monitoring portion of the TMDL implementation. Now, why would you do that? The only reason I can think of for anybody wanting to skip the baseline monitoring is if you can say, I know where my sources are, because the baseline monitoring plan is basically a source tracking plan or program. You're looking for potential sources and you're determining concentration levels for these parameters. If you can already say that I know all the sources, I know where it's coming from, and I have already established a baseline, I know what my current concentrations are in that TMDL body of water, I don't need to gather more data, I'm ready to move forward. Okay, option A may be the choice you'll want to take. I doubt that very few of you are in that position because what you'll see, most of these TMDLs are dated. They were written a number of years ago. The data was collected even longer ago. So the question you're going to ask is the data that was collected to prepare a TMDL that was written in 2008 indicative of current conditions? Or have things changed within my municipality or jurisdiction, county, wherever you might be working out of? Most likely the answer is yes. We've seen a lot of growth. A lot of things have happened. And so data collected many years ago may not be representative of the current conditions or what you're seeing today. So but again, if you take option A, you're going to waive your opportunity to collect new data to move forward with. If you do take option A, and again, you say, I know where my sources are, I don't need to collect any more data because I know what the current concentrations are, you're going to move right into the TMDL pollutant reduction plan. All right, the pollutant reduction plan is the plan you're going to put together that explains how you're going to reduce the loading of that pollutant of concern, POC, in that TMDL body of water. That's your pollutant reduction plan. It's going to be, that plan is going to state what BMPs you're going to use, where you're going to place those BMPs, how you're going to maintain those BMPs, and what your anticipated reduction is going to be through the use of those BMPs. So basically, it's the plan you're going to present that says, here's how I'm going to reduce the levels and get them back into or meeting state water quality criteria. So you have no more than 3 years from TMDL effective date to have your pollutant reduction plan ready to go. No more than 3 years from the TMDL effective date. Again, the TMDL effective date is June 1, 2022. So this plan needs to be in place and running by June 1, 2025. Okay, sounds like it's quite a ways away. It's not really. It's moving in. You know, it's closing in fairly quickly. You'll have to write the plan, and there's a lot of thought that goes into your reduction plan. And also, if we look at the bottom requirement, TMDL pollutant monitoring plan, the TMDL pollutant monitoring plan is your long-range plan for monitoring the TMDL body to determine whether the BMPs in the program, the reduction plan program you have in place, is effective. Okay, are those BMPs reducing the loading to the stream, and are we seeing the levels of those pollutants of concern trending in the right direction? Are we moving towards compliance? So if you're going to have a pollutant reduction plan, and that's the plan that's going to stipulate which BMPs you're going to put where and how you're going to manage, maintain, and go about that. And that could be, it also includes your public education and outreach program. What kind of public education outreach program are you going to have? Who are you going to try to reach, and how are you going to try to reach them with this message? And then your long-term or your pollutant monitoring plan is your long-term monitoring. At this point, think of that monitoring plan as basically for the rest of your life. This permit is going to have a TMDL aspect in it every time it gets renewed for a long, long time. And the current position is, even if your pollutant reduction plan reduces the loading to the point where those bodies of water are meeting the state water quality criteria, it's no longer impaired. DEQ's position is the reason those levels have come down and you're meeting water quality criteria requirements is because of the BMPs and the program you put in place. So if you were to discontinue that work, the expectation is the numbers would start to rise and the water body goes back into impairment. So you're going to continue to have a pollutant reduction plan, BMPs in place of some sort. There's been some discussion over the years, and I think DEQ is agreeable to, if you can show that a pollutant source has been removed or eliminated, okay, maybe you don't need all of the BMPs that you've currently been operating. And so you might be able to back off on some as long as you can continue to show that you have an effective program and that body of water meets water quality criteria and stays in compliance. But that'll be on an individual basis and can be worked out in the future. But in the meantime, you're going to have a reduction plan. You're going to have a monitoring plan. And those have to be ready to go by June 1, 2025, if you take option A. So let's talk about option B, which my guess 90% if not all of you are going to take option B. So again, SWMP review and evaluation, no more than 2 years from TMDL effective date, no different than option A. The big difference here that we're going to see first is the TMDL pollutant baseline monitoring plan. And for option B, no more than 3 years from the TMDL effective date. So the baseline monitoring plan, and I mentioned before, but basically it's a source tracking plan. You're going to be canvassing your watersheds, the sub-watersheds, the basins that drain to this TMDL water, looking for sources, trying to determine where they're coming from and what your current concentrations are. What is the baseline? There's been some confusion because what you'll notice is if you look at that one, we're talking about TMDL pollutant baseline monitoring plan and TMDL pollutant monitoring plan is used back and forth in both of those. Keep in mind, these are two separate plans. Anytime you see pollutant monitoring plan, what DEQ is referring to is the long-range monitoring of that body of water. If it says baseline monitoring, that's the shorter-term program designed to identify sources and determine current loading for that water body. So your pollutant baseline monitoring plan, you have no more than 3 years from the TMDL effective date. So that needs to be out by and ready to go up and running by June 1, 2025. So we still have some time. Don't panic on that yet. But you will, again, we'll talk more about the QUAP and the baseline monitoring plan in a little bit, but you have to have those two components ready to go before you're ready to start your pollutant baseline monitoring plan. Now, the next line, your TMDL pollutant reduction plan, again, that's the plan you're going to put in place to reduce the loading. It's going to stipulate where your BMPs, which BMPs you're going to select, where you're going to place them, how you're going to manage them, and so on, maintain them. So you have no more than 5 years after implementation of the baseline monitoring plan. And you have 3 years to implement the plan. So the baseline monitoring plan must be implemented by June 1, 2025. And then 5 years from that date, you have to have your pollutant reduction plan and your pollutant monitoring plan ready to go. That puts you out to 2030. So we have time. The good thing about what DEQ did on this particular permit is everybody recognized the lack of current data that you're going to be working with. It's difficult to make scientifically sound decisions on old data when we know circumstances have changed considerably over the last period of years. So what DEQ is doing here is they're giving you an opportunity to go out there and collect current data before you have to start making decisions on which BMPs would be best to implement and where to place them. Okay, so that's a good thing. You're going to have 5 years to collect data, to have a good feel, to gather a good feeling for what are my current levels. Because again, your permit requires you to show effectiveness, okay, BMP effectiveness. So you're going to have to be able to show, once you start running your pollutant reduction plan and get into your long range monitoring, you're going to have to show that the BMPs you have in place are effective. Water, the water quality is trending in the right direction. It's getting cleaner. It's moving towards meeting the state water quality criteria goals for that body of water. Okay, so hopefully that kind of explains what's in the table and gives you kind of a timeline or a feeling for where we're going. So again, we've got 3 years from the TMDL effective date, so we still have time. We're working on the QUAP. I've talked to a number of people over the last couple of years since the permit came out, and the general consensus was they wanted help with a QUAP, writing a QUAP. Before you can write an EPA approvable QUAP, you're supposed to complete EPA's QUAP school training program, so that you know what goes into a QUAP. An EPA approvable QUAP has some real specific requirements in it. You have to address certain topics. You have to put some thought into writing the QUAP. You have to know in advance how you're going to deal with different issues that pop up in a sampling program. Okay, the whole purpose of a QUAP is to make sure everybody is doing work and basically producing the same level or caliber of data so that it can be used. Data produced or data gathered that is not gathered under an EPA approvable QUAP or an EPA approved QUAP is not, should not, and cannot be used for permit compliance or for regulatory purposes. Okay, you can still use it for screening purposes, but if it's for permit compliance or regulatory work, it needs to be performed under a QUAP. So what I've agreed to do, and I'm working with DEQ on this, is preparing a template for a QUAP. And I've got the draft off to DEQ. DEQ has worked on a review of that. It's coming back to me. I'll make adjustments and changes on that. We still have some things to discuss and work out on what needs to be in the QUAP and how it's going to be addressed. But in the end, when this is finished, we'll have a TMDL, a QUAP a template that you can use. Now, obviously, it's a template, and so it's going to have to be fitted to each of your situations. I can't put all of the TMDL waters and everybody's needs into the template, but it'll be a guideline and a template for preparing a QUAP, which I think will make it much, much easier for you in the long run. You won't have to go through all of the basic steps in preparing a QUAP. You'll have the outline. So, and when it's finished and it's released, we'll put it out there. Anybody that wants to use it can. You're not required to use it. If you would rather write your own QUAP, as long as it is EPA approvable, then that will be okay too. So, but we'll make that available, and anybody that wants to use the QUAP template can do so. The other requirement before you start collecting any samples is that you have a baseline monitoring plan. And the plan is going to say where, it's going to stipulate where you're going to collect samples, how you're going to collect samples, when you're going to collect samples, how many samples are you going to collect, how are you going to collect those samples, what kind of containers are you going to use, what preservative is necessary, who's going to do the analytical work, how are you going to get them to your lab within the holding times, how you're going to evaluate the data when it comes back, what are you going to do with the data. So all of that will be written into your baseline monitoring plan. And so once again, I'm working with DEQ on a baseline monitoring plan. Once that is ready to go, we'll have a template that you can use, and it'll just be a matter of going in and filling in your basic information for your jurisdiction. Now, there's going to be a lot of changes in the plan as you go. The QUAP and the baseline monitoring plan will be living documents because you'll be making changes, especially during that baseline monitoring period, because what you're doing, again, to keep in mind here, what you're doing is you're looking for the sources. And so, for instance, you might say, I have a TMDL river that runs through my jurisdiction, and it has 6 tributaries draining my jurisdiction. Okay, so you might go back to all 6 of those tributaries and have subwatersheds, a subwatershed for each of those tributaries, and you might decide to sample upstream of the mouth of that tributary so that it's not being affected by the TMDL water for whatever parameter is you're testing for. After you collect a number of samples, you might be able to say that tributary C is contributing 60% of the load, whereas tributary B is only contributing 5% of the load, and maybe another tributary is contributing 15%. And so you're identifying subwatersheds that are major contributors to that impairment. And what you may be able to do then, focus your attention on those subwatersheds, move on up that watershed. So you've only been sampling near the mouth of that tributary. Now you might move farther up that watershed and start collecting samples. And if those samples near the top of the watershed are giving you really low values, then the problem doesn't seem to be in the headwaters of that tributary. Move downstream a little way. So you're going to be moving around during the baseline monitoring plan, trying and sampling at different locations, trying to narrow down the areas that are contributing the greatest amounts of pollutant. Okay, so after a little while, you might decide that a sampling site that you thought looked real promising early on really doesn't appear to be reflecting a high priority area within your watershed. You're going to close that one down and start another one. Start sampling somewhere else. And hopefully in the end, within the 5-year period, you'll have a real good feel for what the loading is in your TMDL water and where the sources are. So you can focus your reduction plan BMPs in those areas. So that's kind of where we're headed on that. So once again, we're working on a QOP template, and we're also working on a baseline monitoring plan template. And when those are ready, we'll make those available. And you can use them if you want to. You don't have to if you don't want to. It's totally up to you. But I think it will save you some time. All right. So now
Vernon, we lost your audio. Hopefully it's not just me. You might turn off your video.
back in.
Okay. I think maybe we can hear you.
Okay, so we're back.
Yeah.
Right.
Goodness.
Right. Stop sharing and share again.
Yeah, and you might turn off your video just in case. That helps save some bandwidth for you. That helped Jamie, I think, a little bit.
Okay, there it goes.
Yep, we can see your slide. Thank you.
Okay, we're ready to go. Monitoring plan, and this is optional. Again, you don't have to participate in the baseline monitoring. My guess is pretty much everybody is going to do so. So your MS4 may participate in a coordinated regional baseline monitoring plan or develop their own individual plan. The plan should be designed to determine the existing levels of POCs. So again, setting baselines in your MS4's discharges and identifying high priority areas which may benefit from targeted BMPs. So basically what this says is if you want to develop your own individual plan for your jurisdiction, you can do so, and it'll just be a standalone plan. If you want to partner with adjoining jurisdictions that have a TMDL obligation for the same body of water that you do, you can enter a regional plan with them. So there might be a few people that decide, well, we want to do a regional plan. We're going to work together. We're going to come up with one regional plan and just move forward with that. The devil's in the details on that one. You're going to have to make sure that what you're going to have to do on that is decide who's going to collect the samples, which samples, where, who's going to do what portions of the work are required in the whole program, and how costs are going to be allocated between your jurisdictions. So, but DEQ gives you the option if you'd like to do a regional or participate in a regional baseline monitoring plan, you can do so, or you can just set up your own plan and move forward. All right, monitoring requirements. So, and again, monitoring, when it says monitoring requirements, oftentimes, generally, that's going to mean long-term monitoring. If they're referring to baseline monitoring, it usually says baseline monitoring requirements. So Section 4B5 says monitoring requirements. So this is your monitoring program or your long-term monitoring program. At a minimum, the monitoring plans shall provide, and you're going to have a detailed description of the program goals, monitoring plan, sampling, and analytical methods, a list and map of the selected TMDL pollutant monitoring sites, the frequency of data collected to occur at each station or site, the parameters to be measured relative to the TMDL or TMDLs, and the quality assurance project plan that complies with EPA requirements. So before you get to long-range monitoring, you're already going to have a baseline monitoring plan. And so what you're going to be doing at the end of that 5-year data collection period is modifying your baseline monitoring plan into a long-range monitoring plan. So once you go into long-range monitoring, you're going to want to have fixed monitoring sites, locations where you're going to collect samples, whatever your frequency is, on a regular basis. And you're not going to want to move those monitoring sites around at this point. So during baseline monitoring, yes, you're going to be shifting your monitoring sites around, looking for sources and trying to determine levels. They're going to be moving maybe at a fairly frequent basis. But once you enter your monitoring program or long-range monitoring, you're going to want to have fixed sites, because again, what you're going to have to show is that the BMPs you're implementing are effective in reducing the loading to that body of water. If you keep moving your monitoring sites around, you're not going to have the baseline data to show what the baseline level or base level was. So ideally, by the time you get to your monitoring phase, you're going to have identified, or you will have already identified, your long-range monitoring sites, and then you're going to collect samples at those sites. And if your BMPs are working, then hopefully we'll see the data trending in the right direction. Currently, there are no requirements in the permit that say you must reduce loading by a certain percentage or anything like that, or at a certain rate. The TMDL does go into some of that, but at this point, what DEQ wants to see is trends in the right direction. And so be able to do that, you're going to have to know what your current levels are so you can show that the trend is in the right direction, or it is positive. Therefore, your BMPs are working. Okay. All right, Quality Assurance Project Plan, or QAP. And this is just basic information. The QAP describes the policies and procedures for ensuring that a work, processes, products, or services satisfies expectations or specifications. The QAP also documents how quality assurance and quality control are applied to your environmental data to ensure that the results obtained are of the type and quality needed and expected. You'll frequently hear people refer to QA/QC, and sometimes they use these terms interchangeably, when in fact they're actually two different components of a quality program. Quality assurance is not the same as quality control. Quality assurance is what you do upfront to ensure the level of quality you're looking for. So that's all. That's from a field perspective, if you're collecting samples, quality assurance is how you're going to collect the samples, what containers you're going to use, how you're going to preserve those samples, how quickly you're going to get those to the lab, you're going to meet the holding times on that. That's all quality assurance, and it kind of sets the guidelines, and that can all be written up in an SOP, standard operating procedure, if you want, but it's also going to be in your QAP as well. Okay, so that's QA. What you're going to do up front to ensure that the data you get in the end is accurate and suitable. QC, on the other hand, is your quality control, and those are the checks at the back end of the program that verify that your QA program is working. Okay, so QC is what you do at the end. So QC, well, just take, for instance, the laboratory that's going to be running the samples for you. QA is the upfront work, and that's going to stipulate how often they run blanks and how often they run check standards and how they clean their equipment and how they purge between samples and so on and so forth. It's going to have, which standards they're going to use and the times of analysis and all of that laboratory information. Basically, the setup of the equipment. The QC, on the other hand, are the checks that you're going to use at the end to make sure that everything worked. You're going to look at your blanks and make sure your blanks are clean. You're going to look at your duplicates or replicate samples and make sure your relative percent difference is within certain ranges. You're going to look at your standards, your calibration standards, and make sure the instrument is capable of seeing the levels and values that you're expecting. So QA is what you do up front. QC is the control measures you have that you use to verify the accuracy of your QA program. All right, EPA requires that all environmental data used in decision-making be supported by an approved QAP. And so what they're saying there, environmental data used in decision-making, that can be, again, either for permit compliance or regulatory purposes. So any data you're using for permit compliance or regulatory purpose, and this program is compliance, must be supported by an approved QAP. So again, we're working on that. We'll make that available, a template, when we have that ready to go. Your QAP should include the following groups of elements. And so there are definite sections in every QAP, things that have to be in there. You're going to talk about your project management, who's going to do what, and who has authority over what portions. Data generation and acquisition, how you're going to collect your samples, how you're going to generate data. Assessment and oversight, what are you going to do with the data once you get it back? How are you going to assess that data? And then data validation and usability, how you're going to validate the accuracy of that data and usability. And there are a number of other sections in there too. Now, if you do use a QAP template that we're working on, there are definite sections in that QAP. Please don't delete any sections. Even if you say it doesn't pertain to my particular project, leave it in there, because if you take it out, somebody's going to say, oh, they didn't address this portion. So if a section in the QAP doesn't pertain to what you're doing, you just write not applicable in there, leave that section in, and that way it isn't mistaken as an oversight or an incomplete QAP. So leave all the sections in the QAP. All right, pollution reduction plan. Section 4B2 states, TMDL pollutant reduction plan. Your MS4 shall participate in a coordinated regional pollutant reduction plan or develop their own individual plan. The plan must incorporate all approved TMDLs addressing the MS4 stormwater discharges and place emphasis on all the POCs or pollutants of concern associated with the impairments. At a minimum, the plan shall provide the following items. And so it goes on to talk about what needs to be in your pollutant reduction plan. So that's the portion that you're going to go into, the phase you're going to go into 5 years after you implement your baseline monitoring plan. So you want to keep that in mind, because you're generating the data you're going to need during baseline monitoring to conduct pollutant reduction. Okay. All right. And 4B3 states TMDL pollutant monitoring plan. So this is your long-range monitoring. Your MS4 shall participate in a coordinated regional pollutant monitoring plan or develop their own individual plan. The plan should be designed to establish the effectiveness of the selected BMPs and demonstrate progress towards achieving the reduction goals of the TMDLs or watershed plans and eventual attainment of water quality standards. So that's the goal of the whole TMDL program, is to bring a body of water back into compliance. And that's what you're going to have to show in the end, that the BMPs you have in place are effective. The water quality is trending in the right direction and you are working your way towards compliance. Once you implement your reduction plan, you have your BMPs in place. If after a period of time you're unable to show that water is trending, the water quality is trending in the right direction, and you are working towards achieving compliance, then we need to go back and look at the BMPs, because for whatever reason, we either haven't addressed the sources we need to address, or the BMPs have not been effective. So have to take a look at the program again. You're probably going to have to add BMPs or move BMPs until we figure out a plan that will address the sources and the issues. Okay, existing approved TMDLs. Section 4B8 states, existing approved TMDLs. The following table, Table 4.2, lists existing approved TMDLs at the time of permit issuance, which are affected by MS4 stormwater discharges. This permit serves as notification of the requirement to implement these TMDLs for the applicable MS4 discharges. DEQ will provide written notification to MS4 sources identified in these TMDLs that are not subject to this permit. So basically what this says is when the permit came out, June 1 of 2021, that was notification of your need to comply with TMDL requirements. However, DEQ and EPA knew it was going to take a while to get programs implemented, and so they didn't make the TMDL requirements active until June 1, 2022. So you had a whole year after the permit came out to review, read, and get comfortable with TMDL requirements, okay? And you're not the only ones that have TMDL requirements. I've heard from some people, well, how come I am doing this? But a neighboring jurisdiction that doesn't have an MS4 permit does not have to do anything under the TMDL program or the TMDL it's released. And in your permit, it does say DEQ will provide written notification to MS4 sources identified in these TMDLs that are not subject to this permit, being the OKR04 permit. So at some point, DEQ will start notifying some of these other communities that have obligations under the TMDL that they will have requirements as well. So, all right, looking at the table, Table 4.2, and this is just a portion of the table, and I'm just using this as an example so you can kind of get a feel for what's in the table. This is in your OKR04 permit. You want to look at this table, study this table, because this is the table that's going to tell you which TMDLs you have to comply with, which ones affect you. And so the first entry in there under watershed basin, it's broken down into watershed basins. Basin 1, which is the Middle Arkansas, Verdigris, Neosho rivers. And then TMDL reports. Here are some of the TMDLs that have been issued for that basin. The Neosho River Basin Bacteria TMDL prepared in 2008. Okay, the only MS4 that's listed as a source in that TMDL is the city of Miami. And so Miami does have obligations under the Neosho River Basin Bacteria TMDL of 2008. So they're going to get a copy of that TMDL. They're going to start reviewing, reading that TMDL, understanding what's in there, and getting prepared to comply with the requirements. They're also going to update their SWMP to include those TMDL requirements, and they're going to make notations in their annual report regarding the progress they've made along the way. So what you notice in the last column of that table is effective date. And so when I've been talking about TMDL effective dates, that's the effective date for the TMDL requirements in the permit, and it's June 1, 2022 for all of these TMDLs. So in the Basin 1, Middle Arkansas, Verdigris, Neosho River 1, we also have a Lower Bird Creek Watershed Bacteria TMDL from 2011. We have an Arkansas River and Verdigris River Area Bacteria and Turbidity TMDL from 2012, and we have an Arkansas River and Hakey Creek Bacteria TMDL from 2008. And so when you look at the identified MS4 sources for each one of those TMDLs, you'll see there's Catoosa, Broken Arrow, Wasso, Tulsa, Claremore, Coweta. Now, any jurisdiction can have multiple requirements or be required to comply with multiple TMDL. So it's not like you have one TMDL. Many of you will have more than one TMDL you're going to need to get familiar with and comply with. So what you'll notice here, there's Broken Arrow is listed on 3 of these TMDLs. So Broken Arrow has 3 TMDLs they're going to have to comply with. Tulsa County, looks like I see 2 of them. City of Tulsa, they have 3 TMDLs just in this one basin that they have to comply with. So check this table, pay attention to it, take a close look at table 4.2 in your permit. Find your jurisdiction, your community, or your county under identified MS4 sources, and then go across the table and find out which TMDLs you need to get copies of and get familiar with. Okay. Now, where are you going to find these TMDLs, or how do you find a list of TMDLs? You're going to find these in the integrated reports. So the most recent integrated report, they come out every 2 years, is the 2022 integrated report. And you're going to find these in Appendix E in the integrated report. So the 2022 integrated report for Oklahoma in Appendix E lists 636 completed TMDLs. So yes, there are lots of TMDLs, completed TMDLs in Oklahoma. So, and I just clipped a portion of the table here to use as an example. The far left column is the water body ID. Every body of water that's been studied in Oklahoma has a water body ID number. That number is unique to that stretch of the river or river reach and it's never duplicated or used anywhere else. And the reason for having a water body ID, and you want to get familiar with the water body ID, is because if you just go by water body name, how many Dog Creeks and Cat Creeks and Cow Creeks and Elm Creeks are there in Oklahoma? Lots of them. And so it's going to get real confusing if you say, well, it's Dog Creek. Well, Dog Creek where? Which Dog Creek? Body ID, that's a unique identifier for that piece of water, and it isn't duplicated anywhere else. Okay, so you're going to see that water body ID. Now, what you'll notice under water body ID, like for Mission Creek, it's listed twice. But when you look at the water body ID, it's the same water body ID. So they're talking about the same river reach or piece of water there. When you look at cause, it has it's impaired for Escherichia coli and turbidity. So what that means is that river reach or piece or stretch of water is impaired for both Escherichia coli, a bacteria, and turbidity. When you look to the column just to the right of that TMDL ID, every TMDL has a unique identifier, a number. That particular TMDL is 39220. And then if you look in the last column, it shows the TMDL completion date, which was 2010. So if you're looking for a TMDL, you can go to Appendix E in the integrated report. And if you're looking at an online version, these are live links. So you can click on that link and it'll pull up that TMDL. And then you can copy it or print it or download it and save it wherever you want and have an electronic copy or printed copy of that TMDL. So you want to go through and identify which TMDLs you need to comply with, get copies of those and be reviewing them. Those are the kind of things you're going to be expressing and noting in your annual report. So you've identified the impaired water bodies that you're going to have to deal with, the TMDLs you have copies of the TMDLs, you're reviewing the TMDLs and getting familiar with what your requirements will be. So looking down through, there's a TMDL for Copan Lake, and that brings up a good subject, something we want to touch on. Water quality criteria for lakes is different than water quality criteria for rivers. The process is different, and the template that we're preparing, the QUAP template and baseline monitoring plan that we're preparing, is for rivers and not lakes. It can be used for lakes, but you're going to have to go in and rework portions of it to make it suitable for lakes. And the QUAP and baseline monitoring templates we're working on are for bacteria. So if you have an impairment other than bacteria, if you have a turbidity impairment, a chlorophyll A impairment or something like that, you're going to need to modify that QUAP a little bit before it's appropriate for that particular impairment. But it's still going to save you some time. It gives you an outline, it gives you framework to move forward, so you're not starting from scratch. Okay, but the 2022 integrated report, Appendix E, is where you're going to find a listing of the TMDLs that have been approved and get copies of the TMDLs that you need. Okay, there are 7 TMDL planning basins in Oklahoma, and so this map just shows which planning basin your jurisdiction is in, and then you can look at that planning basin to determine which TMDLs have been prepared. So if we just take a quick look, and obviously we're not going to go through a full TMDL, they can be hundreds of pages long. But this is just the bacteria and turbidity total maximum daily loads for the Arkansas River, Verdigris River, study area, Oklahoma. And then and then that 120400, 120410, so on. Those are water body IDs that are included in that TMDL. That's just the cover page on that. And then if you look back, there's another page in there, and it shows all of the different Oklahoma water body IDs that are covered in that TMDL. So once you find the TMDL, check that table on there and then see which creeks are listed in that TMDL and which ones flow through or you discharge to. That'll help in kind of narrowing down which TMDLs you're going to be working with. All right, and just kind of going through quickly, the planning basins, Basin 1, there are 11 TMDLs. That's the Middle Arkansas Verdigris Neosho River Basin. And this just shows which rivers, what it's impaired for, and then when the TMDL was prepared. And what you're going to notice is you're going to see bacteria over and over and over again, and you're going to see turbidity over and over again. And things like dissolved oxygen and chlorophyll A and a few other things will pop up once in a while. Okay. Planning Basin 2, the Lower Arkansas, only has 2 TMDLs. Planning Basin 3 has 13 TMDLs. That's the Washita and Upper Red. And looking through that, Planning Basin 4 has 5 TMDLs. That's the Lower Red. And those are the TMDLs that have been approved. And then also, DEQ is continually working on, just adding a note here, on TMD. Their position at this point is, even though new TMDLs are going to be approved during this permit cycle, you're not obligated to start work on those TMDLs during this permit period. There's a really good chance those TMDLs will be written into the next OKR04 permit when it gets updated. And so it's not a bad idea to keep an eye on which TMDLs are in the works and about when they're going to be completed, because there's a decent chance you could have additional TMDL requirements for additional bodies of water or rivers pop up in your next permit. But at this point, they're not planning to implement requirements for any TMDLs that are approved during this permit cycle. All right. So Basin 5 is the North Canadian Deep Fork, and there are 8 TMDLs in that one. Basin 6 has 13. That's the Cimarron and Upper Arkansas River. So again, lots of bacteria, an occasional dissolved oxygen, quite a few turbidities, a couple of chlorophyll A's, pretty standard. Planning Basin 7, the last of the basins, has 4 TMDLs, and that's Beaver and Upper Cimarron. And now notice there's actually a minerals TMDL in this one. And that's the end, and we have just a few minutes, I guess, if anybody has any questions. And there's my contact information as well. You've got wonderful resources through COSWA. If you have questions, there are a number of people that can answer questions and help you out. So it's a really good organization. You've got some really good resources within COSWA. If you do want to give me a call or send me an email, I'll be happy to help you out too. No problem. I do work from home about half the time, so don't worry about calling me on my cell phone. If I don't pick up my office phone, there's a good chance it's because I'm at home, and there's a decent chance I'm out fishing or doing something else. So I'll return your call when I get back. But I'll be happy to help you if you have questions or if there's something that I can assist with. Of course, DEQ, you can always call DEQ, and they'll give you a hand and help you answer questions and help you out as well. So and many of you will have questions. This is new for just about everybody. You haven't had to deal with TMDL requirements before. So as the program rolls out, you're bound to have questions. So feel free to reach out. The COSWA folks will help you. I'll give you a hand if necessary if you have questions. And of course, DEQ will always be there to help you as well.
Thank you, Vernon. Such a great presentation with lots of helpful information. If anyone has any questions, be sure to type them into the chat at this time. Jordan, do we have any existing questions?
I did not see any questions come in through the chat, but if you do happen to come up with any questions, please forward those on to us and we'll make sure they get answered.
Cool. All right. Well, as a reminder, everyone in attendance today will receive a certificate of attendance for this special training event. I think we've got everybody's username figured out, so thank you for making sure we got that. And we should be able to get those certificates out in the next few days. Well, and thanks again for attending today's special training event. We hope everyone enjoyed the presentations and learned something new. We hope to see you during the COSWA Christmas party for members and affiliates. It'll be December 13th at 11:30. And then we'll have a meeting shortly thereafter at 2 p.m. Both of these events are going to be at the Station in Moore, which is the same place we had the Christmas party and meeting last year. And we've also invited some special guests to the meeting. Hopefully they can attend. And we're also going to be presenting some very special awards to some of our special guests. Hope to see you there. Have a great afternoon, everyone. And we'll hang out here for just a second in case anyone had any questions.